Hey everybody, instead of doing a after school test study session that only some people might be able to come to because of, activities and things like that, and it's annoying for parents to have to schedule a time to come in and get you. Um, I thought I'd bring it to you. So I'm going to try this out this year by doing video study sessions so that you can watch or listen to it as many times as you want prior to the test. So, what we're going to do is in class on Monday, you received this sheet. This sheet goes over all 45 points on this assessment and what the topics of each of those questions are. So, I'm going to go through the general topics. I'm not giving answers to the test, but I am giving suggestions of things to study or some hints along the way. So, let's go right ahead and start on out. We're going to start with questions 1 through 3. So, questions 1 through 3 are all about SIs. What is an SI? It was one of the first bunnies of this unit. There is two particular answers that you could give. One of them, both of them involve the word units of measure. So think about that. Look in your notes. Try to find that bunny. What is an SI? The other two are, what are the SIs we talked about? What is the SI unit of force? And what is the SI unit of pressure? Find those things in your notes for your studying. All right. The next one, number 4. When calculating a volume, milliliters could also be substituted for what? There will be some stuff about this that you'll have to do a calculation of later on in the test as well. So maybe we'll give the answer away here in a little bit. Uh, Number 5, you need to know what the difference between these two words is. You need to know the difference between weight and mass. So in general, weight is that force of gravity on you in your current location. Think of a scale underneath your feet. Versus mass is the atoms that make you up. The only times you change your atoms are when you eat something or go to the bathroom. So versus your weight can change based on gravitational pull. So if I teleported you to another planet, your weight would change. Your mass would not. For questions 6 through 8, states of matter. So look at your definitions of solid, liquid, and gas. They all include the words either definite shape, definite volume, indefinite shape, indefinite volume. So those definitions, 2 of them are multiple choice questions. One of them will be in the fill in the blank, but you should be able to do some process of elimination on it, because if you have 2 multiple choice questions first, and you know what they are, let's say they're like gas and liquid, well, you probably know that the last one is going to be the definitions for solid, and it'll be different from the other 2. Continuing on, uh, question number 9. Seriously, read the question again. None of you should get that question wrong. I literally tell you the answer in the question and give you a huge hint for the rest of the test. I'm not kidding. Read it again. Don't get it wrong. Please. Like, seriously, please don't get it wrong. All right. Number 10 and number 11, phase changes. So, first of all, we need to know that thermal energy increases as you go from solid to liquid to gas. Now, what are the names of each of these arrows? Solids to liquid. Think about it. Candy bar in pocket. It was solid. It now is a melted candy bar in my pocket. Oh, it's like I said the answer of melting. Now, from liquid to gas, boiling, vaporization. Let's see if I can do this without looking. Condensation should be around here somewhere. And then liquid to solid, if you have a melted candy bar or if you have water in an ice cube tray, you have to freeze it to make it solid again. Moving on to Robert Boyle and Jacques Charles's law. All right, so the 2 laws that we have kind of help each other. So the first one here is going to be Boyle's law. Ooh, let me get a marker. Be right back. I got a marker. All right, so Boyle's law, it's going to be hard to write on this piece of paper. Here, I'll put a folder behind it. Boyle's law says that if you increase pressure, you're going to decrease volume. Increased pressure equals a decrease in volume. The thoughts behind this is if you took a balloon and you squeeze the balloon, the volume of the balloon would want to get smaller. So if you put pressure on it. Now, Charles's law refers to when temperature is increased. So this was the example of me chasing you guys as with a blowtorch, a flamethrower, and you're a gas particle, and you'd run faster. So if we increase temperature, what happens to the volume and the pressure? So what we talked about in class was the idea that if I increase temperature, you would run away so fast that you'd hit into each other harder, increase pressure, hit into tables more, increase pressure, and hit into the walls more, increase pressure. We also talked about the fact that if you were to run that far away to try to get away from me as I'm trying to heat you up, you'd probably break the walls or the door of my classroom. So you'd increase volume. So here's how all of that looks. You would increase the volume and you would increase pressure. That is Charles' law. Thank you, Jacques. Charles. Jacques. All right. We are now moving on to questions 15 through 19. 15 through 19. I'm going to ask you an example, and you're going to say whether it's a physical or a chemical change. Really, the question you should ask yourself is a new substance formed? The tricky one that some of you got wrong on your exit ticket was dissolving. Remember, if you dissolve sugar in water, it's still just sugar water. A new substance has not formed. And you can return it to just sugar by evaporating the water away. All right, the next one, there's going to be 3 pictures. We drew them in our notes, so you should have these very easy. The 3 states of matter are 3 main states of matter, the pictures of how the particles would be set up. You'll have to just identify which one is which. That takes us through number 22. On to 23 through 26. So these are going to be all questions related. My page isn't folding over here. Here we go. Technical difficulty. All right, here we go. 23 to 26 is all about atoms in the periodic table of elements. So the first one is the structure. You should know that protons and neutrons, P's and N's squigglies, are in the middle. That is called the nucleus. Then you have your electrons that go around the outside. We did lots of practice with this for the atomic model project. The other 2 things you should really know is who created the periodic table and how is it organized. So there's 2 particular ways to talk about how it's organized. So we've talked about the atomic number. The atomic number is the main way that it is sorted by number. If you say element number 2, you look at element 2, that is the atomic number 2 is helium. Now, the other one that we talked about was the vertical columns. So the pattern that Dmitry Mendeleev, it's like I just gave you the other answer. It's totally not. The answer is definitely John Cena. You can't see me. Now, the vertical columns on a periodic table are going to be what they react with. So they're all part of a family, except for that one exception. Remember, hydrogen's that weirdo. Hydrogen shouldn't be in that particular spot. All right, 27 and 28. Oh, I almost forgot. Question number 24 is a question that we did not go over. And here is something that I do differently than other teachers. I believe that I can still teach you something new, even if you're taking a test about it. So I'm going to end up giving you the answer to question number, 24. However, it's going to be something that we're going to learn that is a new piece of information that was not necessarily about the standards that we did. So I do throw things like that are meant to be free points, meant to kind of slow you down in the middle of the test as well. All right. 27 and 28. These are fill in the blank with subatomic particles. So you need to know the atomic number is equal to what? There's going to be two fills in the blank. So does the definition make sense to have two different things, maybe two subatomic particles that both equal the same thing as the atomic number? And then the atomic mass is going to be something plus something else. What two subatomic particles add together to equal the mass of, like, I don't know, the nucleus? All right. Ow. I totally hit my elbow right against my computer. I elbowed you in the face. All right. They're so far away. Give me a sec. All right, here we go. Number 29 through 31. You're going to have a chart. There's going to be some blanks in that chart. Names of subatomic particles. Symbols of subatomic particles. Charges of subatomic particles. And AMU, MU, atomic mass units. You're going to have some fill in the blanks from that chart that are going to represent, to fill in the blank piece of information. You should be able to spell proton, neutron, and electron correctly. And that's not saying you have to memorize how to do them. Literally look on your test. Those words will be all over your test. So you really shouldn't misspell anything that is all over your test. Like literally on the same page, a couple inches above that chart are the words proton, neutron, and electron. So yeah, those shouldn't be difficult ones that you have to memorize. All right, going on to states of matter. Oh, not states of matter, properties of matter. So you need to know in general what is the definition of the word matter. And then we're going to talk about this idea of their properties, physical or chemical, very similar to the physical and chemical changes earlier. And then you need to know the difference between mass, volume, and density. So mass is essentially how many atoms make something up. Volume is how much space it takes up. And then density is mass divided by volume. So it's that ratio between how much is in something versus how much space it takes up is density. So that's what you need to know for those multiple choice questions. We are then moving on to calculations. In the calculations, we have volume, a length, times a distance, times a depth. Now they're all measured in centimeters, centimeters, and centimeters, which will give you the unit of centimeters cubed. Centimeters to the third power. Now, within your study guide, those numbers were like 34 and 7. And they multiplied together to get 840, which is, I'm going to go much more mental math. Let's say it's like 2 times 3, which would be 6, times 4, 6 times 4, 24 centimeters cubed. Now, time for density, mass divided by volume. Now, when you calculate that, the problem's going to give you the amount of mass in grams. You're going to divide it by whatever the volume is going to be in the problem that you solve. And then you need to know this final fact, that water equals a density of 1. And if the number is less than 1, it's going to float. If it's more than 1, it will sink in water. We're almost there, people. Let's see. Number, flipping page. 39 through 43. You're going to need to use a periodic table of elements, and you need to understand how to use an element square. So element square in the periodic table. So there's 4 basic pieces of information that are given to you on an element square. That is the atomic number, then the atomic mass, the element's name, and the chemical symbol. However, in questions, whatever the last 3 are, 41, 42, 43, you will need to know how to find all 7 pieces of information. So you'll have to know what those things mean. So you'll have to know the atomic number is equal to the number of protons and the number of electrons in a normal state. You'll also need to know how to find those pesky neutrons. That's the tricky one, remember? Atomic mass minus the number of protons, or your atomic number, is going to leave you with the number of neutrons. So you will have to do 3 problems that are almost identical to the ones that you did on the using the periodic table homework. Finally, the last problems. Here's the diagram. What is this showing? Oh, I didn't even draw a thing in there. I have to draw an item. Here, we'll draw like a little. Thank you. I drew something in there. So here's the whole point. You can find the volume of an object. Volume. Don't you dare say mass. Don't you dare say weight. Volume. You can find the volume of an object by placing it in water. You measure the amount that it goes up, and the amount it goes up, so here from 10 to 40 is 30. 30 milliliters would leave you with the volume of this object as 30 cubic centimeters. So this object volume would be 30 centimeters cubed. So that's how you'd write it. 30 centimeters to the third cubed. Now, I hope we have a great week for our Jeopardy review. I hope you guys watch this. And remember, your study guide is due on Wednesday, and we're going to have a great time throughout the week. Let me know if you have any questions. Take care, everybody. Bye.